What are the odds of a size that you get when eating the sandwich in Times Square? The game says that you get a random size but never specifies the actual probability of it. That bothered me for quite a long time. Sure, one can make estimates of how rare each size is based from experience, but Jeff mates have big brains. I mean, just look at our head hitbox. So, I started noting stuff for the past week. After eating a sandwich in regular form, I increased the count for the specific size I get. You can have the experimental probability, which is the rough estimate, by simply dividing the number of times I got the size to the total number of sandwiches I ate for the experiment. And if you know statistics, the bigger the sample size, the closer it is to the actual probability. Maybe I'll continue recording the data from time to time. Speaking of actual probability, it's possibly hard-coded by the devs unless they use a different way to determine the size that you get. Let's try to make more of the data I have right now and derive patterns from it, making assumptions based on logical reasoning. If there is a value selected by the devs, they would try to make the uneven odds somewhat uniform for simplicity. Let's assume that the numbers that are close to each other have the same actual value or odds. You can notice that the second and third biggest together with the first and second smallest have similar numbers. So does the third smallest compared to the fourth biggest. Only the largest size is definitely rarer from the others. This distribution makes sense if you think about it game-wise. If players want to have fun with said sizes, you would want it noticeably different from the regular size but not big enough that we occupy the entire Times Square, hence the low probability for the biggest size. As for the third smallest and fourth biggest, they're visually noticeable too, but not as much as the others. Less difference in size might be less fun, leading to the probability of it being lower than the more common ones. Now, let's do a little bit of algebra. Please don't scroll away here or sleep on me. We need to expand our brains to counter the brain rotting. So, we good? Alright. These four sizes look to have the same probability, so let's denote them as X. These two also have a relatively similar probability. They will be represented as Y. The rarest and last one will just be Z. Tying them all together, we create the algebraic expression of 4x plus 2y plus z equals 100. But we notice that the third smallest and fourth biggest size is just half of x in the sample. We could also say that z is just 1/12 of x, which is the odds of getting the biggest compared to getting one of the sizes of x. With these new terms, we can only have x left in the equation through substitution. We're left with 5 and 1/12 of x equals 100%. So my hypothetical probabilities for the sizes are as follows. Second to third biggest and first to second smallest get around 19.67% each. Third smallest and fourth biggest would each be half of that. And if those all total to 98.35%, subtracting it by 100 leaves us the probability of the biggest size, which is 1.65%. Matches closely with 1 out of 58. Well, we really didn't change much to begin with. Of course, the actual odds may be more or less, but something is still better than nothing, right? You can also eat another sandwich after 30 minutes have passed. I wasn't able to note it, but there was one time I got the same size again. Regardless, eating the sandwich as soon as possible is still the fastest way to get a different size. If you want to retain your size, the best way to do so is to wait for your current size to be gone first, then eat again. Overall, with this new knowledge, I can simulate gacha to get more dopamine from eating a virtual sandwich, and host more pool parties in the disco when I actually hit the jackpot. Just remember to take everything I said with a grain of salt. But have you ever wondered,